everyone. This is Joe Smo. I accidentally forgot to plug in the mic. That typically helps. As you can tell, I'm not very good at the recording the first time and not messing up. Dealio. So, today we will be discussing how to use opcodes and what are status flags. So this is your introductory to like basic coding, all with assembly. So this is going to be a lot to take in. There's no real way to make you good at this beyond doing it yourself and looking up the stuff. So if you want to begin to get at this and like really like achieve a lot of stuff here, you want to go to www.6502, which is the CPU that the NES uses, .org/emark tutorials/emark 6502 opcodes.html. There you will find that basically all the stuff about what I'm talking about. And if you want to find status flagging, what I discussed today, you can go to NESDev status flags. You don't have to type that in. I just like in any particular order. It's just easier to cool like that, and it should pop up. Okay, so the first thing we need to learn is like what are the ways you can address like variables and whatnot. Like, so like you have variables, you have like all x's and y's going on. You might look at that and be like, and I already got rid of some that are even more complicated. It's like you got like stuff going on here. Like somebody went crazy here. Like what sane person does this stuff? Like no. Luckily, just for the sake of making it so you can actually learn stuff, we're going to ignore these. Okay, those are bad. Okay, they're complicated. I don't want to talk about them today. They deserve their own video. And they're just complicated. Okay? And you don't really need to learn them until you do some really complicated stuff. Like picking 27 different places to warp, and you pick one of those and then you warp there. Complicated, but sometimes useful. And typically there's routines that can do it for you already. So just use those and they will somehow miraculously work. Okay? So that's easier to use. Please use those if you haven't learned those already. Especially if you're a beginner. Dine jump is the typical one to use for SMB3. Well, let's begin actually talking about these. So we already discussed the scary ones and why we won't be discussing them. So the immediate. This means you load a direct number to it. Like you add with carry a number. You're adding 1. Right? So let's say var in this example equals 5. You add 5. If equals 7, you add 7. Okay? And that variable can be any variable. It can be variable 1, 2, 3, 4, so on. Doesn't really matter as long as it's a variable. It doesn't care. It actually can be. It doesn't have to be like RAM. It can be ROM as well. You just if you're gonna do it in ROM, that you would probably not do it like this though. You probably do something like this, where x or y would equal something. So a very important thing to understand is that there are a few registers when doing coding. These are the 3 most important registers to know. There's the accumulator, there's the X register, and there's the Y registers. These are ones you can affect easily. So there are a few other ones. So there's the PC, which is where the program counter is at, as well. There is the stack counter, which you can also use as well. And beyond that, there's nothing you can really use for register wise. So going on that, so you guys, so basically var x comma y. So if let's say we have 0 0 comma 1 1 comma 2 2 3 3 so on, and we can do like, so just for this example, this isn't how you set up numbers, but let's pretend it is for a second. So x. So let's say x equals 0. It's going to go here. It's not going to go anywhere. That's the first number. It's going to look up there. Let's pretend var starts right here, right? So var bam. Okay. So it starts right here. It's going to go right there. Bam. Done. Right? If x equals 0. If x equals 1, it's going to go here and read that number. If y equals 3, it's going to read that number. So on. And if y equals 27, it's going to read down into this list, into the code. And that's going to be bad, so don't do that. Unless you want some weird effects. Okay? Okay, so now we're going to be discussing the status flags. Most important is the carry flag. Use this the one the most when pairing. You can use it a lot for like mathy stuff. You change it by math, dividing, increasing, decreasing, setting it, clearing it. So basically, if you do math, you don't want to change it. If you load a number, you don't want to change it. Actually, you're not going to change it if you load a number, because it's carry flag and you don't change it with that. 0, you do change. If the register is ever 0, it's going to be 0. Capiche? You can also, I think, use bit as well, but that's kind of a wonky instruction that we won't be discussing too much into. Interrupt disabled. I'm just going to say don't worry about it. It affects v-blanks and stuff, which is very complicated, to say the least, and deserves its own video. A decimal helps with the negative flag. So these are buddies, okay? They're happy buddies. Happy buddies. Happy buddies, okay? Alright, they're happy buddies. They have like a little friendship thing going on here. And basically, decimal affects how the negative flag gets used. So if decimal is set, it uses decimal, which means the very first byte in every number gets used to determine if it's negative or if it's positive, right? And the funny thing about how this works is it's kind of a bit weird, okay? So you would imagine, like any logical person, that 0 0, so 0 0 equals actually 0 0, right? But then you minus 0 1. What would that equal? Well, it actually equals FF, right? Which would equal, in your mind, negative 127, right? That makes sense in my mind. But actually, what it decides to do is that equals negative 0 1. They did that so it equals numbers easier, but it's a bit confusing to wrap your head around, and why on earth they would ever make it so complicated. So if you're at 80 and you subtract 1, so let's write this out, and what a human would see. So this is negative 128 minus 1 equals, you guessed it, 7F, or 127, because wham, computer logic. So yeah, so decimal set, it uses this. If it doesn't, it's just straight up from 0 to 256. And then there's also the overflow flag, which tells when the number overflows. Let me make sure OBS is working still. Good, it's nice and happy. Okay, so I just got here before I realized the recording wasn't working well. So in this example, I was showing off how you make indexes. So we load to X. So we did original thing here. So I'm going to comment this out. Don't worry about that. Okay, so this would be 3, right? Load A, which loads a value. It can be a variable, it can be anything. And then we add by 1, and then we store it to the temporary, right? So let's say we wanted to, load an array, and we want to start with 2 and then decrement, right? That's something you would want to do. Let's make it a bigger number, right? Because we want to be cool. Let's make it 5. Okay, so that's 6 off for the computer. So we want to say, yeah. So we already made the magical array of fun times. We can put a colon there. You don't really need to do that, but you can. It makes life a lot easier to read. And then we want to write dot byte. I think you can also do db or something like that as well for this, but Visual Studio likes when you do that. So then you're gonna write your first number. Then I'm gonna write another number. As you see, it doesn't really matter if I write it like this, like that, or if I want to say a variable. So num equals 1. I can write num negative 126, comma, ff, comma, 1. Okay, so that will work. Please don't do that. Like, no one will be able to figure out what on earth you're doing if you do that, but that's just an example. Okay, 1. Okay, so let's say you want to actually read this. So let's make start of routine. Right? We're first loading to X, and with it, then we're going to loop. So when you do a loop that's backwards, you use a negative sign. When you loop forward, you use a plus sign. We're looping backwards in this case, so we're just going to put that there as a reminder that we're going to loop backwards. Okay, we're going to do this multiple times so you understand exactly what I mean. Okay, so we're going to load X5. This does nothing. Load A02. So instead of 02, let's do magical array of fun times. And then we're going to write X. So now, if it's X equals 5, it's going to go here. If it's 4, it goes there. 3, 2, 1, 0. Cool? Okay. So now, because we want to loop through and we want to start the temp variable, and let's say we want to index that as well by X. So it's going to load a number into each one of the temp variables, right? There's like, so you're just going to go by the offset. Okay, so no longer it's going to equal 3. We probably want to write a comment somewhere. Say like, oh yeah, we're looping, right? We can actually call this loop. If you want, you can call it loop. So now we know it's loop, and then we want to say, so as we said, branch are not equal. You probably don't know what that means yet. You can kind of guess by the name. We're going to do negative loop. Okay, so whenever this is not equal, it's going to loop back over here, right? So how does the computer know if this is not equal? Well, we have the 0 flag. 0 flag, and then we put a little guy in here. There we go. Beautiful. And now we have 0 flag. So until it reaches 0, it will continue to loop. So it's going to loop through all 6 times. So you add 1 to that number because it's the way we did it. So then let's say you want to branch on when it's equal. So we can load a, let's say we want to do that again. I'm going to think of how I want to do this. So I'm going to load a 0, 0. Then I want to load an X. So let's say we want to load another number again because we accidentally overrode it or something weird. We can do like negative loop again. Well, we actually got to put that somewhere, but like we can branch on equal like that. No, that's going to foreverly loop. Mac. But that's good to know as well. Actually, let's use this time to actually learn a new command. So we're going to use the compare command. And let's say 2. And we're going to make a new variable. I want to use another variable. So, so typically when you make a new variable, any of like this stuff, what you want to do is you want to find your SMB3, and you see these are variables. So let's pretend that we want to use map unused. So we're on the map, I guess. I want to use this. My changes. Okay, so first we want to load a 0 0. That basically that sets. So let me write some comments here. Set to 0. Load 5 to x. Okay. And then we need to say loop. That was high pitch. Okay, so now. Okay, so instead of. There's a few ways we can do this. The way I would do this is I would use the increase command. What does the increase command do, you may ask? Well, it increases the value by 1. So we already set it to 0, so now it's going to equal 1. And now we're going to load that value into the game. We increased it, that doesn't make it show up, it just goes through that value and it puts 1 more to that value. Okay? So it's going to first be 0, it's going to increase, come here, and then it's going to be 2, and then it's going to compare to this, it's going to be equal to that, right? Because 2 minus 2 equals 0. Think about that. You can also, instead of doing this, you can say subtract. Sorry, it's not like that. You say subtract with carry, and then you also want to do the clear carry, which clears the carry before you subtract. That's also an important element to remember. So we also have the macro. So instead of writing this, which is annoying, you have to write 2 things to do 1 thing. Instead, you can just write subtract 0 2. That works as well because this is for a later video. But we have macros. Macros will be heavily utilized by the assembler or the ROM for when we. I don't know, actually, maybe it doesn't have it, but basically, I'm pretty sure it does. But it will be heavily utilized to provide a lot of magical changes to the ROM easily. So that's nice. So it doesn't have that, and I don't really want to do that anyways. Instead, compare. So you would only. So the reason why you use compare over subtract with carry is that compare doesn't affect the value. It only checks the value. So it's like, yeah, 2 minus 2 equals 0, but the value still equals 2 in A. Okay. So when I refer to A, I mean A as the accumulator minus 2 equals 0. Okay, therefore it doesn't loop anymore. Okay, so now we might want to begin to, let me think. Okay, let's do a few more. So let's do the bitwise operation. So we want to load A. Oh, we can do hash percent. Okay, now we can write numbers. So 111000. Okay, now we'll write and hash percent 00 111100. Okay. Okay. This is going to make A equal percent 00 110000. Okay. So let me make sure. Yep, that's exactly how I want it to look. So that's just a way to just get the thing you want. Right. So let's say you load up a value and each bit equals something. You can use that to check it. Another fancy way to do that is bit. I believe it's for the 6th So percent, if you were to do load a, so you always want to use bit over doing the other method. First, load a val, so like let's say temporary, because that's the one we've been using, and 0, 1, 0. That's how I check to make sure I didn't add too many zeros or whatnot, because it can get a bit confusing. So this checks the first bit, and it, I believe, if you remember right, it affects the overflow flag if bit 6. So reading from the status flags, bit will load bit 6 of the address value directly into the v flag. So if it's set, so if this number is true, it's going to load that into the overflow flag, and then you can check the overflow flag with, I forget exactly what the exact abbreviation is. It is, okay, BVCS. So then you do BV that. Okay. So this branch on, let me try to type on overflow set. Or you can do BV, I don't use this often, in case you can't tell. Tab branch on overflow declare. Okay. Let's say so let's pretend like there's a positive loop up here. Okay, we want to loop through that again. So let's pretend there's another value up here. So we're just going to put a plus down there. So if this is true, it's going to go to positive, and if negative, we may go down here, I guess. And as you see, you can make negatives, names, and stuff. You see the negative one goes backwards, the forward one go forward. We got a lot of good things going on here. But they really haven't got too overly complicated yet. I'm not like understanding it, right? You can tell, oh, so it jumps there, it's set so it jumps, right? So some other things I want to mention. So before we continue, if we load to x a value, we can also compare that. We write px, and then we can do that, and then we can write on equal. Let's write equal. We can also do that with y. So instead of writing x, write the x. That doesn't sound good. Something like fell behind me, I think. Instead of increase, you can do decrease. You do decrease. Let me see if there's any other simple instructions that we can discuss. Okay, so now I want to begin to do some more complicated instructions. Let me see if I can pull up. See, I want to. Actually, that's not. Let's say that's a different video. Okay, so I was going to show you how to do some rotation of bits without affecting everything, because the instruction I want to talk about is LSR. So the way you say that would be logic shift right. So if I did 0, 0, 0, 0, 0, 1, this would make it equal percent 0, 0, 0, 0, 0, 0, 1, 0 instead. Okay, and if I say logic shift, wait, okay, you actually can't do this like that because it's not smart. So we can do load A, and then you write A, and now it's annoying. That annoys me so much. I wish you could just write LSR just writes for you, but instead they're not that smart. Okay. Yeah. So 1 0. So you might wonder what happens if we have something like this, right? You would assume this would go and equal the logical conclusion of, oops, 0 0 0 0 0 0 0 1. Okay, but that's not how that works. Instead, equals, you guessed it, 0 0 0 with carry equaling set. Yep. And then this one, carry not set. What? Might be like, that's kind of weird. I gotta agree. That's weird. Let me verify. Oh, I did this wrong a little bit. Okay, so I thought we were shifting things left. This is logic shift right, and I forgot how things work when you do that. So it would be the other way around. So this would equal this. Very set. Sorry guys, as you can tell, OPCodes are kind of complicated. Okay, so if you follow along this long, I gotta congratulate you. You really know your stuff, and you can follow along. Oh yeah, there's also not. It literally does nothing. So we're just gonna put a big sad face there because it does nothing. You know what? It's gonna be crying too because I don't know. Oh, it's just gonna do that now. Let me see. Okay. So this is the okay. So the logic shift. So there's logic shift right, and I forget the other name. There's a lot of opcodes, so it takes a little bit of time to remove them all. Yeah, ASL. So ASL works the other way around. And also when you load a something and load a like 0 0, and let's say there was the carry was set, so I think it's so the carry is set, so it's set, and let's say we do so either way we do this, if we use a logic shift left, it won't do anything, it still will equal 0, so 0 0. So that's nice, but let's say you wanted to keep that in. What you would do is you would use rotate right and rotate left. These are so much easier to remember because they have nice names that make sense. Okay, so let's say A and A, and let's set carry again, right? Set carry. Okay, so this will then equal, so it's rotating right, the carry, which means it goes from that side, so it will equal 80. Or 1 0 0 0 0 0. Okay, and then this would bring it back to the carry. So let's do 2, so we can really begin to figure out how that. I don't want to add it with carry. Sorry, game. This will then equal 1. Okay. So now I think I got rid of all the very simplest of instructions out of the way. So now that so this is just for the main line instructions, so we're not going to be, so there are 2 more instructions I want to discuss. There is the ORA, which works like and, but it's, so if you're familiar with C, it's like the instruction, like, think about it like this, 20 or 2, right? And the and instruction would be like 1 and. That's delayed. Oops. Let me try this again. 1 and. I'm not having a good time right now. Okay, there we go. So it would be like that. Okay, so think about like that. So the way you say that is ORA. So load A, number 0, 1. So that's the first bit, and let's say 80. So that's the last bit. This would equal. It would equal. Actually, that's a bad example. Let's say 81 and 80, right? Out of that, it would equal. Actually, let's have another bit in there. 3. So now it would equal. Thinking about it, it would equal 83 because let's make it 82. So that would. So this would equal 83. I don't know why I did that. Okay. Now you're gonna work. Okay, 83. Because the 1, and there's the second bit, and then there's the last bit that stays. Okay. And then there's the exclusive OR. How do I write this? I know you begin with E. So yeah, you definitely want to use 6502 opcodes.org. It really saves a lot of time trying to figure out how on earth some of these work. Okay, it's EO. Okay, so this works a little bit differently. So we get 81. So we load A, 82. The order doesn't really matter. This will return the 80 gets removed because they're both set. Therefore, it doesn't work. Let me make sure. Actually, I'm forgetting. Let me verify some stuff. I don't want to tell you incorrect information. So EOR 6502. So basically, is exclusive, or I don't want to. So it's not telling me anything. But basically, if both are set, I think if both are negative, I think so. I actually need to write this out because this is complicated. So this is the most complicated thing we'll be discussing. Okay, so you get 0, 0, 1. See, I forgot a 0 there. Then this is 0. Oops, forgot the sign. So you think about this. So this would then equal 0. That doesn't work. 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 This works. Okay, I think that's how that works. Yeah. So it would equal 3. So 3. Okay. So that's how that would work. A little bit complicated to get used to. It's used occasionally. Has its perks. Why not? And then other values to keep in mind. I don't know why I did that. The clear and set carry. Clear interrupt. Set interrupt. Clear overflow. Clear decimal. Set decimal. Okay. Okay, so I just want to give an introduction to how the program counter works, so the PC. So let me delete some lines so we can go down a little bit more. Okay, so now we got a nice flush palette of stuff to talk about. So the PC. So so the ROM reads from 00 to FFFF, right? Now you might be thinking, well, Joe, that is true, but that's not exactly how much. There isn't just how many bytes that is. I think it's like 64,000 bytes in the game. There's more like let me think. There's like precisely 256 kilobytes of data, Joe, and that is nowhere near, you know, 16 kilobytes or whatever. And half of that's like used by the NES. So I don't really want to get into how that works with the NES. We're just going to talk about simple stuff here, as simple as we can get it. Basically, the PC, it keeps track of where it is. It uses this. This is going to be very important. And another thing to think about. So let's say you were at address 1100, right? It's actually read like this. If you use hex, you might know that it's kind of annoying. Luckily here, it doesn't matter until you do some complicated stuff. So we're just going to mention it now. Begin introducing it as a concept. And so yeah, that's fun. So when we address anything, we're going to be using that so you remember that's how things work. I know it's confusing, and I personally think it's annoying, but I guess it makes it easy for the computer, and that's what counts back then. So let's say I want to jump to address 768. Okay, so I want to address 768 like that. So that's address 768. So let's put a comment. 0768. I know. That amazing, right? So if you want to know exactly what's at 768, you can go to the compiler here. You can look around. So this is 0 page. That's not going to be useful. I guess I can talk about that as well, because that's also something to keep in mind. It doesn't really matter. We're getting close. 718. From the last video. So 768 is part of the object's color cycle. That's kind of lame. So let's see if we can find something else. I don't feel confident in any of this. So let's just say the random pool. Right, we're going to change some numbers around and make the player have a bedtime. So let's. Oh, what's that number again? Okay, so it is at 781. So 781, just so remember that. So 81. 81. 781 now. Beautiful. So read set instruction. So let's say there's an instruction there. That's how the ROM sees it. Okay. Another thing to count is that it's constantly counting up. Okay. So that's so basically when you write your code, you want to write it so it goes like. I'm not going to do anything too complicated here. Nom, right? And let's say we have bytes. These bytes are going to be interpreted as instructions after the code site. So let's say the PC's here, right? So PC's here, and it's really happy right now. Okay, it is having the time of its life, and it's chilling. Okay, it goes to the knob. It does nothing. It is, it's just chilling there. Still chilling, taking a nap. It's taking a siesta. It's literally doing nothing. It takes another siesta. Okay, so now it's here. Okay, so now the computer reads 0000. Computer, PC's like, it's mega sad now. And because computers are stupid, it's like, it doesn't know what to do. So it's like, okay, Bob. So then it goes back to, it's like, boss. It's like, I don't know what to do, Bobby. It's like, oh, let's try to reset the game. If it gets really bad, or it might break, or it might do something other annoying thing, and basically they don't do what you want, because that's not good. Okay, you don't want that. Okay, so what you need to do, so the game doesn't freak out, you need to add this instruction. RTS. Now this is kind of a lie. You don't always need to do that, but for the general sake of argument here, you're going to do the RTS instruction. Basically, this returns from the instruction. If the code continues and you don't want to edit what's after that, you want it to continue to read that, you want to continue it. But if it ends, you need to put this in, or else the game will freak out and we'll have a bad time. Okay. So, that's something to keep in mind. I don't really want to get into much discussion about that right now, because it's a little bit complicated, and I think this video is already plenty complicated enough. Yeah. So, let's just do a quick review. Load A, load stuff. Load X, load stuff to the X. Load Y, load stuff to Y. Stow to A. Stow to Y is Y. Stow to X is X. B and E branch on not equal. BEQ branch on equal. So that's when the overflow is set. So when you're ending stuff, this is just something to keep in mind right now. Not really important to remember, but just know that happens. You will use it like 2 times. The game like uses it 2 times. You know, it's just something to keep in the back of your head. So you'd be like, I used that 1 time. Okay, compare Y, compare X, compare is compare A. Okay, so then we got logic shifts right, arithmetic logic shift, I believe, or something like that, and no, arithmetic shift left, because it can just be like logic shift left, because that's just too easy to remember. Those get rid of the carry after it's used. Rotate right, rotate left, keep it. Maybe in a future episode we will talk about how to just do 8-bit. So you only use all 8 registers. It still uses all 9. Because that's how life works. You can't skip the 9th one, but it's just, but you can't pretend like you didn't. Yeah. And then exclusive error and just the regular one. Which, if you like have programming experience, hopefully isn't too complicated to understand. And then Nop, he's so happy because he does nothing. I think I'll put this out like 1 too many. It doesn't matter. Yeah. Oh, and the X's and Y's for offsets. Those are fun too. So hopefully this video has at least gave you some really good a good idea of how to begin. Actually, you know what? Let's actually discuss the status flags again. So the carry for math, 0 is like always used. This is like the biggest one. If you just couldn't remember anything, remember the 0 flag and BEQ and B and E. Okay. Negative, decimal. Kind of complicated. I'm not gonna lie. It's a little bit of a pain to get used to. Alright, it's like, why on earth did anyone make it so complicated? I know. Tell me about it, man. Decimal, you gotta make sure decimal's used. You find out really quick. Another thing about that, so like, if decimal isn't used in this segment, it's going to have a really bad time doing this negative loop because it can't go backwards. So you probably want to keep that in mind. But typically it's set because it's useful for that reason. Else you would have to do slightly different instruction. So like We haven't got to this yet because it's a little bit complicated. I don't really want to talk about it. But what you can do is, so let's use the plus. So branch. So it's branch on not equal. So we're gonna do branch on equal plus, and then we can jump to negative loop. Now that was not that's complicated. I know, but it's something you can do. So remember it. But yeah. So hopefully you'll learn at least a little bit of something today. And the second video of learning about the compiler. This one isn't exclusive to the compiler. Hex editing also is very useful to know all this. You actually would need to know a lot more than that. Like, so each one of these have special values assigned to them. So like add with carry absolute is 6D. I know. I don't know why that is. It just is. They have values. And with carry, immediate 29. Don't know why. It just is. So that's also something important to note. That's really why hex editing is just such a pain. You gotta remember that. If it didn't require that and you just write add with carry, honestly, it would be 20 times faster. But sadly, that's not how life works. So without any further ado, hopefully you had a good time, enjoyed the video, learned something, and made a positive influence on yourself. Signing off, Joe Smile.